Now, the lesson, I will admit, is a little strange to teach students because I think it's easier to teach when it's just like step 1, you do this. Step 2, you do that. Step 3, you check it by doing this, right? But this lesson was more so about all the different ways you could find patterns, and those patterns might not be easy to see for all of you. So some of the things we looked at when we're trying to find relationships between values, like in a table of values, is that you could see if there's a pattern between the x's from one x to another, between the y's from one y to another, from the x to the y, like something like that. Or like adding up the x and y gives us the same amount, multiplying the x and y gives us the same amount for each one. Like there's lots of things that you can look at that can help you come up with the equations, but really like the rest of the school year, it's gonna be a lot easier because we'll be looking at something like a linear equation, for example. And I'll teach you that those are set up as y equals mx plus b. So that if you see that something's changing by a consistent amount, that you should use that setup and things like that. So it will get easier. It's just an overarching lesson that's like, here's how you read a table of values and here's how you can maybe find those numbers. So don't get too hung up on it if you didn't quite like the lesson or get it the first time, it will get better. But the main things you need to know from the lesson are that x is also known as your what? Input, and y is also known as your input. That too. But like input, output, y is usually what is dependent on x. So like, yes, your dependent variable. And x is what's independent. So independent / input, they both start with in. But the x's are usually chosen for you. Like if we're evaluating the amount of rainfall each day, then x might be day 1, day 2, day 3, day 4, like things that you can't change what day it is. And then y would be like in that random example I just made, the inches of rainfall or something like that. You know, I don't know. But something along those lines, independent versus dependent. What we saw in the lesson today were things that for sure have relationships. So that random example I made probably isn't good, but let me think of one. In all the examples you saw today, there were relationships and there are equations that define them. Whatever equation you choose as defining it, check to see that it makes sense. So in this one, this random example I made, what's a pattern that you can see? Okay, in the y's, it keeps adding by 5. Anything else? It goes up by 1 in the x. So as x is increasing, so is the y, and the y is increasing by 5 each time. When we are making our equation, we're usually doing something to x to get the y. So what's something I could do to 1 to get 5? So what both of you said is correct. You can try adding 4. You can try multiplying 4. But only one of them will work for each situation. So if I add 4 to each x, do I get each y? So if I multiply by 5 each time, do I get each y? So that's what we mean. Like once you think you find the right equation that represents it, it should work for each input output here. Because usually you're doing something to the x. Okay, and then that thing that is staying consistent, like multiplying by 5 each time, would be represented with a number. And the things that vary each time are your variables, your independent and dependent variables. So there's that, that's like the gist of the lesson in really simple terms. You do have a practice that goes with it. So try it, it might be a little tricky. If you need help as you go, please ask me. I feel like yesterday, I feel like everyone just waited until I checked in and then we kind of ran out of time to go over everything. So please ask as you go. I do like to help people at their desk, like I'll come to you and I can try to talk you through it. And if you still don't get it, you could ask on the screen later. But I like to try to help you get there on your own, so I'll be over and I'll help you out. So 80% or higher on the practice. We did unit 2, lesson 3 today. 80% or higher is the minimum requirement before you move on to other things. Okay? Questions? So Tyler needs to complete this table for his consumer science class. He knows 1 tablespoon contains 3 teaspoons and 1 cup contains 16 tablespoons. And you have a lot of pieces that are missing. So if I'm going from cups to teaspoons, I should expect like the number to get bigger, I guess. Because how many tablespoons are in a cup? In 1 cup? And if I have 2 of them, how many do I have? Like how many tablespoons, I mean? So it gives you any conversions you need, it's giving them to you. So if we know that there are 16 tablespoons in 1 cup, but I have 2 cups, then how many tablespoons do I have? And what math are you doing to do that? Right? Because we had to, but we're multiplying actually by 16 by however many cups we have. So like even right here where we have 3 cups to get the tablespoons, I'd have to times it by 16 and that would be 48 and blah, blah, blah. If I want to go from tablespoons to teaspoons, what do I need to do? What math? How many teaspoons are in a tablespoon? 3. It says so right here. 1 tablespoon contains 3 teaspoons. So if I have 32 tablespoons, how many teaspoons do I have? 96. So however many tablespoons I have to times it by 3 to get this. And now when I work the opposite direction, so I'm going from teaspoons to tablespoons. So I should expect the number to get smaller if I'm going from teaspoons to tablespoons. 36 divided by 3 does give me 12. If I have to go from tablespoons to cups, would that even be a full cup? No, it would be a fraction or probably a decimal is more so what it wants. But the math that I'm having to do here is divide by what? How many tablespoons are in a cup? And when I do that math, the decimal I get, it didn't specify it wants a fraction or a decimal. So I'm going to go with that. It wants a decimal. And I'm going to put 0.75 or 0.75. We'll see what variations it accepts and which ones it doesn't. But yeah, that makes sense because that's less than a full cup, which I know is 16 tablespoons. So be able to work in either direction. Now we're missing the teaspoons again. I have the tablespoon, so I'm gonna work from there. How many teaspoons are in a tablespoon? So what math do I need to do to get this blank? Multiply your tablespoons by 3. So 48 times 3 is 144. Okay. Now that is, I guess, testing your problem solving skills. Like people tell me all the time, oh, I don't need an equation. I know like to find this, all I have to do is this. Great. But the next step is to make an equation that represents it. And right now we're comparing teaspoons to cups. So I need to be able to do something to the numbers in this column and get the numbers in that column. So think about what we did when we worked this direction. From cups to teaspoons. What did I do like to the 2 to get 32? What did I do? What math did I do to the 2 to get 32? And then what did I do to that again to get 96, my answer for teaspoons? I multiplied that by what did I do to 32 to get 96? So this will give me my number of teaspoons. Taking my cups, which in this random situation, I had 2, but it's varying each time. Taking my cups, multiplying it by 16 to get my tablespoons, and then multiplying it again by 3 to get my teaspoons. Now, I don't think it wants you to type it like that, so we're going to kind of condense it. Does order matter in multiplication? No. So I'm going to do 16 times 3, make that just one number. 16 times 3 is 48. I can condense it to 48 times C gives me T, and the T is for teaspoons. And see if that works. Is 48 times 2, 96? Do it in your calculator if you need to. 48 times 2, is that 96? Is 0.75 times 48? Is that 36? Is 3 times 48, 144? Yeah. So that's the expression it wants. It wants you to put something that no matter what I plug in, I get an output. And let's see all the different ways that you could have typed it that it would have accepted. If you typed it right, but it just didn't accept it, but it was right, like you could tell me and I'll fix it for you. But it could be 48C, same thing. I guess all that's changing each time is like how they wrote the 0.75. So this needs to be some variation of 48 times C, like you could do parentheses around the 48 and then times the C something, but it needs to show basically 48 times C. Yes? It shouldn't matter if it's lowercase or capital. It's not case sensitive, so it doesn't have to be one or the other. Good question. When in doubt, just follow their instructions. They have a capital C, so I would just use that. All right, but any questions on that? Questions on others? Aiden? Question?
Oh, question 6.
Okay, so Priya is hosting a poetry club meeting this week and plans to have fruit punch and cheese for the meeting. So this one's kind of like the one from the last homework, if you remember, like the milk and the cookies. But anyway, she's preparing 8 ounces of fruit punch per person, 2 ounces of cheese per person, including herself. There's 12 people. A package of cheese contains this much and costs this much. A 1 gallon jug of fruit punch contains this much and costs that much. We're letting P be number of people in the club, F be ounces of fruit punch, and C be ounces of cheese, and B being her budget. So it's almost exactly like the one from the last lesson, but now different numbers. This is like when we do our reviews and then we'll test. All right, but anyway, we're gonna select all that could represent quantities and constraints. So basically evaluate what each of these mean. So like the first one says F equals 8 times 12. I'm gonna go back and reread my paragraph, find where it talks about what F represents. And that's ounces of fruit punch. So we're basically trying to see, does 8 times 12 give me the ounces of fruit punch? I'm gonna go back and read some more. She wants to have, of the 12 people in the club, she wants them to each have 8 ounces of fruit punch. Would timesing that give me the total ounces I need? Yeah, right? That makes sense? So I would select that one from the list. It might be shuffled on yours, so don't blindly pick the ones that we are. But yeah, that would give me my ounces of fruit punch I need. So now check the next one. It says C equals, so C would be the ounces of cheese that I need. And they're doing 2 times $3.99. $3.99 was the cost of the cheese. It did mention we want 2 ounces of cheese per person. Would timesing 2 by $3.99 give me how many ounces of cheese I need? Right, it wouldn't. That would give me, that, I don't even know what that would do. But if I wanted how many cheese I need per person, well, there's 12 people in the club, I have to do 12 times 2, that is not a big. So now take the next one. I like looking at what's alone on one side to see what it could possibly be. So on this one, what's alone is the B, and the B is like for budget. So think of what contributes to that budget. That would be like the cost of things, is what I should expect on the other side. So over here I have 8 times F plus 2C. We know F is how many ounces I need of fruit punch. You know, C is how many ounces I need of cheese. Does timesing it by 8 and 2 give me something about the cost? That was a lot of words, and I'm saying a lot of words. Stay with me. Would doing this math contribute to the total she needs to spend? I would disagree. Because if I'm contributing to the budget, I would need like the cost on the other side, and this one doesn't have that. It has how much you need per person times how much I need per person. That doesn't make sense. I'm not gonna take that one. The other one with the B that has the dollar amounts, that so far looks like it makes sense. We have the cost of each package shown. Let's see if we should multiply it by those numbers. So if there's 12 people and we want them to each have 2 ounces of cheese, what's 12 times 2? And a package of cheese contains 16 ounces. So how many packages do I need to buy? 2, and they are multiplying it by $3.99. So far that looks good. Over here, it's just plus 250. So let me see how many ounces of fruit punch I need. If you want each of the 12 people to have 8 ounces of fruit punch with 8 times 12.
$96.
Okay, good. Should this, and 1 gallon of fruit punch has 128 ounces. I only need 96 ounces. So how many gallons do I need to buy? Just 1. And it costs $2.50. And that's why that makes sense. So like 1 times 250 would be 250. So I would take that one. Last one we need to check. We have 2P equals C. C being ounces of cheese I need. And P being number of people in the club. So would timesing 2 by my number of people in the club tell me how much cheese I need? Okay, I'm seeing some head shakes, no. Remember, we said we want each person to have 2 ounces of cheese. So doing 2 times my number of people, which was 12 right now, they're showing it as a variable, 2 times my number of people does give me the ounces of cheese I need, we did that earlier. So that would represent it. I know it's like a lot of reading, a lot of going back and checking. But you just have to see what each variable represents and think like, does that logically make sense? Should I do those operations to get the amount of cheese I need? And my budget. And my food punch, like, does it make sense? Okay, question? Okay, other questions at all? Not a time for one more. Hayden? Number 2. So this one, number 2, the members of the band sold juice and popcorn at a college football game to raise money for an upcoming trip. The band raised $2,000. The amount raised is divided equally among the members of the band, which equation represents the amount that each one receives. When in doubt, what the lesson was trying to teach you earlier today was that when in doubt, you could try making a table of values. What's independent is my members of the band, like my number of members. Cause we don't know what that is, that sounds like it could vary. And A being the amount each person gets. We know that they are splitting $2,000 equally among them. So if there's just one member of the band, which there wouldn't be, but like if there's just one member, how much would that one member get? Okay, good. If there's 2 members of the band, how much would each person get? There's only 2,000. So they're splitting it between the 2, they would each get 1,000, right? They're splitting them equally among each other. Let's do another one for good measure. If there's 2,000 people or $2,000 split between 3 people, each person gets around $667 approximately. So think of the math we just did. In each situation, depending on how many members I have, we did division, only 2 of these have division in them. So we're gonna exclude the ones that don't. Which one gives me how much each person gets? It could be shuffled on your screen, but Cadence. Good, that's correct. So I know it's weird, you have to like think about the math you're doing in each situation, maybe make a table of values if that's not clear. If they're splitting it equally among them, that is division, right? Do some of the math, be able to plug in some of the numbers and see like, does it make sense? If it's the rule, it should work for each one. And then I think that's all it's. So if you still have questions, don't be shy. Kind of like what your quiz will be. Yeah, make sure you have good notes. Make sure you can check your answers and you need to.